Hello, my name is Kelly Farron, and I'm going to talk about the recent AWS DynamoDB service disruption. On October 19th at 11:48 p.m., an unlikely interaction took place deep inside of a data center in Northern Virginia. Many of the most used applications in the world suddenly dark. One AWS service, a database service called DynamoDB in the US East 1 region, had been disrupted. And as a result, 141 dependent AWS services found themselves inoperable. So, what happened? According to AWS, the root cause of this issue was a latent race condition in the DynamoDB DNS management system that resulted in an incorrect empty DNS record for the service's regional endpoint that the automation failed to repair. Okay, what does that really mean? Let's break it down. The root cause was an issue with DNS, or Domain Name Service. The purpose of DNS is to translate human-readable domain names like google.com into an IP address that a client computer can use to actually find where google.com is. The DNS resolution for DynamoDB is a two-part system comprised of a DNS planner and a DNS enactor. The DNS planner is what plans changes to the DNS. It periodically creates new DNS plans, which group together load balancers in a manner that's appropriate for the current traffic. In the US East 1 region, despite having 3 availability zones, there is only one DNS planner to simplify the management of all the shared resources. Then there's the DNS enactor. The DNS enactor takes a plan generated by the DNS planner and puts that plan into action, propagating it to each endpoint in the region. The US East 1 region has 3 DNS enactors which operate concurrently, one enactor per availability zone. Here's a helpful visualization of how this system actually works. The planner makes new plans, which are picked up by the enactors, which actually put the plans into action. So what was that unlikely interaction that caused the downfall of US East 1 on October 19th? Well, typically a DNS enactor picks up the latest plan created by the DNS planner, and before beginning to enact that plan, it makes a one-time check that the plan it intends to enact is newer than the plan that was previously enacted. If the current plan is newer than the previous plan, the DNS enactor begins to work through the endpoints which require updating. As there are 3 DNS enactors working concurrently, it's possible that during this process, one DNS enactor will be blocked by another updating a same endpoint. In this case, the enactor just retries each endpoint until all have been successfully updated. On October 19th, for an unknown reason, one DNS enactor experienced an abnormally long delay starting its enactment process, and thus it needed to retry its update on several endpoints. While the DNS enactor slowly worked through its endpoints, 2 things continued to happen. First, the DNS planner continued to make new DNS plans, and second, another DNS enactor picked up a latest plan and began quickly working through all of its endpoints. The second, faster DNS enactor then finishes working through its endpoints, and so begins its cleanup process, which takes place every time a DNS enactor finishes enacting a new plan. The cleanup process identifies and deletes plans that are older than the one that was just applied, and this is where we run into trouble. At the same time that the faster DNS enactor initiated its cleanup process, the slower DNS enactor applied its stale plan to the DynamoDB endpoint, overriding the newer plan that was just enacted by the faster DNS enactor. As the faster enactor worked through its cleanup process, it identified the plan enacted by the first DNS enactor as being much older than the plan it just applied, and so it deleted it. The result of this was that all IP addresses for the US East 1 DynamoDB endpoint were deleted. No clients of DynamoDB in US East 1 region can find DynamoDB. Now, I mentioned earlier that the US East 1 region has 3 availability zones, specifically designed to preserve availability across the region. Why didn't these zones alleviate the issue? The answer lies in the fact that it was the US East 1 region that was affected. This is the oldest and largest AWS region, and thus it controls several crucial cross-regional services like STS, Secure Token Service, IAM, Identity Access Management, S3, EC2, and more. These cross-regional services are dependent on US East 1 DynamoDB, and thus, as all availability zones rely on the same control plane services, the loss of the US East 1 DynamoDB endpoint affected all availability zones. The initial failure occurred at 11:48 p.m., and about 2 hours later, the root cause of the failure was identified. After this, engineers began to manually restore the DynamoDB endpoints, and it wasn't until about 4:15 a.m. that the core DNS issue was resolved. The true amount of financial loss incurred from this is still to be exactly determined. However, according to cyber risk analysis firm CyberCube, the estimated range is between $38 to $581 million. The availability for DynamoDB is quantified as the percentage of requests processed by DynamoDB that do not fail with errors within each 5-minute interval. The outlined monthly uptime percentages for DynamoDB are 4 nines for the standard service level agreement and 5 nines for the global tables service level agreement. The difference between standard and global tables being that the standard SLA applies when an application's tables are only in one region, and the global tables SLA applies when the tables are replicated across regions. So what should be done going forward? A most important client-side recommendation is to identify services that are critical to keeping your application running and architect your application to allow failover to another region if a threshold of failures has been exceeded. In the case of another US East failure, where central services like identity management are unavailable, know how to log in to AWS using your root user and password, and know how to do so quickly and easily. It's not clear yet what AWS has done to mitigate this issue long term. However, a recommendation could be to more closely monitor the latencies of individual DNS enactors, so that if an enactor experiences an unusual delay, which could lead to a subsequent race condition, reinitiate a check on the age of the plan that an actor is trying to implement before the actual implementation takes place. This event raises a larger question about the current state of the infrastructure of cloud computing. How interdependent is the internet? As more services move to the cloud to reap its benefits, it should be well understood how interconnected the cloud and the larger internet really is. The more devices that are connected to the cloud, which can directly impact human lives, not just business and school applications, but smart IoT devices, smart metered power grids, or water treatment plants, there should be careful checks in place to ensure that a failure in one service does not cause massive failures throughout the US and throughout the world at large. Just some food for thought.